For this, our last example of the semester, we have that 7 buildings in a college are connected by the sidewalks shown in the figure. The weighted graph represents buildings as vertices, sidewalks as edges, and sidewalk lengths as their weights. A hurricane has knocked trees over onto the sidewalks, and campus decides to clear as little as possible so that they can still ensure students walking from building to building won't have to get over the trees. Determine the shortest series of sidewalks to clear, and then find the total length of the sidewalks that need to be cleared. So, we have our pictures here, and our goal is going to be to use Kruskal's algorithm to find a minimum spanning tree. That is, a minimum set of paths we could take where all buildings are still connected, not by trees. Yeah, this is confusing little notation there when our trees get into our trees and we need to find more trees. This is a lot going on, but we're going to do this carefully. We're going to look at that picture, we're going to find the pieces that we need to make this work. So, we need that minimum spanning tree. If we're going to use Kruskal's algorithm, we're going to start by taking the smallest edge, which here would be FG with a weight of 242. From there, we can take the next smallest pretty much freely, which would be BD at 245, and then AD at 249. But we have to be careful there, because you're taking both BD and AD, that means BA, or AB, if you want to do it alphabetically, would create a circuit, so we cannot, under any circumstances, take AB, even though it is technically the next smallest. So you have to avoid that one and instead go on to DG, but notice that because we took DG, that would then remove AG from our possibilities, which isn't really an issue because that's actually the longest one, but hey, that worked out nicely. From there, we want to pick the next smallest available, which would be CD at 253, but getting CD would mean removing BC, as well as CF and CG. So our options are actually starting to get pretty limited at this point. That's the nice thing about Kruskal's algorithm, is you kick out a lot of pieces along the way. Anyway, once you get there, because we have so few things left, we really only need to take one more, which would be CE, to get our minimum spanning tree like so, which would correspond to a total distance of 242 plus 245 plus 249 plus 251 plus 253 plus 259 for a total length of 1,449 feet. And that's how you run the algorithm, that's how you get our answer, and that's our last piece of the semester. It's been a long one this year. It felt like a long one. I don't know. Maybe it's just me. It's been a tough year. It's been a lot of tough years recently. But it's been a pleasure working with you all. Happy you all took this class with me. I hope you all enjoyed your experience here. Good luck with our exam. Good luck with your exams in other classes, whatever final papers you have to finish up here over our last few weeks. And when you're done, have a wonderful break, everyone. It's been a pleasure working with you.